let's solve a question asked in WhatsApp quiz on this Saturday. Now, in the question, it is asked, if a car is moving with constant velocity parallel to x-axis away from the origin, what is its angular momentum with respect to the origin? So, as we can see in the figure, there is a car shown which is moving in a direction parallel to x-axis. So basically the road is parallel to x-axis and car is moving with constant velocity v, and they are asking you what will happen with its angular momentum, whether it will be zero, increasing, constant or decreasing. Now, as we can understand quite easily that this question is based on a mechanics and a concept of angular momentum, let's try to understand first of all what is angular momentum. Angular momentum of object of mass m and velocity v bar is given by L is equal to m r bar cross v bar. Now m is the mass of the object, r bar is the radius vector or you can say position vector, and v bar is of course the velocity vector. Now it is very important to understand how we got this definition. Basically, the angular momentum is considered as a cross product of the position vector of the object moving in motion or moving in a rotational motion and the linear momentum. Okay, linear momentum. Now this linear momentum vector is actually a product of mass and velocity. So from this we got this definition that angular momentum is equal to m into r bar cross v bar, which if we simplify we get mvr sine of theta. Okay, now let's come to this case where they are saying that the object of mass m and velocity v is moving in a straight line, however it is parallel to x-axis. So let me draw xy coordinate system here for my reference, and let me show a line parallel to x-axis like this. This is x-axis, this is y-axis. Let's say the object is of mass m, okay, and initially it is at point A and moving with velocity v. Then at some other instant the object of the same mass m and velocity v is at point B. The point A has a position vector of, let's say, r1 bar with the angle of theta 1 with the x-axis or reference axis, and let's consider the position vector for object when it is at point B is r2 bar with angle as theta 2. Now as we know from the definition of angular momentum, LA has to be a product of m v, okay, r1 into sine theta 1. Now what is this r1 sine theta 1? Thus r1 sine theta 1 is nothing but the vertical component of r1, which you can represent by h. So basically this h is nothing but a distance between these two parallel lines, a line across which or along which the object is moving and the reference axis. So this h is the distance or you can say vertical component of r bar. So from that we can get LA is equal to mvh. I can refer this as equation number 1. Now let's consider the angular momentum at another point LB. Now by using the same definition we can write it as mv r2 sine of theta 2, where r2 sine theta 2 represents a vertical component of r2 bar, right? But if you resolve this r2 bar, you can understand the vertical component of r2 bar is again the same distance what we have considered in first case. So by that logic again we can write m LB is equal to mvh. right? So I can consider this as equation number 2. So this was my equation number 1 and this is my equation number 2. From both the equation it is quite clear that if an object is moving in a direction parallel to x-axis with constant velocity vector, then its angular momentum irrespective of its position and the time instant remains constant. So we will be going with the option that angular momentum of the car remains constant. Thank you.